Good morning, everybody. Thank you for showing up. Weird behavior I have. Okay. I didn't say proper. Photo chiffon. Good morning, everybody. Today I want to find 2 or 3 equilibrium and best response strategies. So let's find it. Now I should share. Control Shift 2. Then we are going to. Oh my god. We're seeing all of them. So Expedia not for now. We want to find the equilibriums first. So it was the previous one. Let's summarize it. Where is it? 1. Okay, S1t plus 1 is alpha S1t plus P1. Okay. S1t plus 1. I think we can ask those questions once we have a solution for this one first. S1t plus 1 alpha S1t plus P1 dun. Alright, everything good. So we are setting the price. We are finding an equilibrium, like a stable solution, right? P1, P2. So it will be S1 is alpha S1 plus P1, this S1 plus gamma B1 is greater than S2 plus gamma B2. S1 will be alpha S1 plus R1. Yes. Does not depend on S0. Yes. And S1 plus gamma B1 S2 gamma B2 will end up in this. P1 R1 1 minus alpha plus gamma B1 P2 R2 1 minus alpha plus gamma B2. So we have situation A, we have situation B, and A intersection B requires depends on initial state. P1 R1 gamma P1 C. That doesn't happen, right? Okay. So we show that it is true. What is this one? Okay. All good. So let's clean up this part first. Get rid of the computations. And we want to consider utility now. P1 R1 1 minus alpha plus gamma B plus gamma B1 P2 R2 1 minus alpha gamma B2. This is A. P2 R1 minus alpha 1 B1. Listen. Um, right. So otherwise, if you change the sign of the inequalities, we will have B Okay, that's it. Now let's look at the utilities. Right, what are the utility for this function? I want the utilities to be we make money from each sale. We are losing money on buying a sponsorship, and what are these? Okay, not this. Okay, that's utility. So price times with probability P1 you sell. That's true. Okay. Keep the energy up, guys. Keep. So now let's bring utility. P1 1s1t plus gamma b1 t is to t. Sounds good. And let's say once we consider the stable case, u1 equals P1, which is the stable price, times P1 plus P2 right? That sounds good. And now we want to say, what do we want to say? The same for the other guy. Let's have it helps us. right? That's it. And now we want to say what do we want to say? We want to say what is the equilibrium or best response. So let's assume we are in situation A, where actually A minus B, right? P1, R1. Okay, what are the strategies? The strategy is P1, the price, which is not in the condition here. Oh, it is in R1. And P2, R2 plus gamma B2. So let's assume we are in A minus B. Let's do it step by step, guys. We have a lot of time. A minus B. So what does that mean? Copy. Paste. Big comma between S1 P1 R1 over 1. Right? That sounds really good. And these are the situation, right? Now U1 is this, U2 is this, then U1 will be P1, P1, right? S1 plus gamma B1 will be greater than S2 plus gamma B2. So P1 plus minus M B1 and U2 will be P2 M B2, right? Let's find the best response. Finding the best response to P2 and B2. All right. So we are trying to maximize U1 P1 P1 minus MB1 over P1 and P1, right? There are variables subject to these constraints. Only those two, right? A and B. Okay, subject to P1 R1 Q1 minus P1 over 1 minus alpha plus gamma B1 and P2 and oh my god, P2R1 2 Okay, first of all, A minus B, it's obvious that, okay, A is this, right? P1 R1 plus gamma B1, B is P2 R1 plus. A minus B is when A is happening, which we have it here, P1 R1 minus 1 minus alpha plus gamma B1 right? Because remember, the situation here is A union B is M. So A minus B is actually B prime. And B minus A equals A prime. Right? Or I should write. So that's the situation here. So once we have A minus A, so B prime, therefore B prime is subset of A. So once we have like both constraint, we wanna just limit ourselves to it's obvious, by the way, like P1 R1 minus alpha gamma P1. When this is true, when the right hand side is right inequality is true, the left hand side of the left inequality is greater than left hand side of the right inequality. Right hand side of the left inequality is greater than right hand side of the right inequality. So I can just say I should just change this to P2 change this to P1, right? So we have two variables, one constraint. We want to maximize U1, so we want to have P1 as big as possible, while our constraint wants P1 to be as low as possible, and B1 as low as possible. We don't want to, make sense, right? We want to charge the consumer more. If we could, we wanted to charge the consumer more because it made us more revenue, and we wanted to pay less for the sponsorship. While on the constraint, it's quite the opposite, because paying a sponsorship brings your state high, and charging a lot brings your rating down. So our utility and our constraints are completely against each other. So no problem, right? What should we do is, it gives us an upper bound for P1, P1 will be gamma B1 minus B2 minus P1 Q2 minus P2 1 minus alpha, right? So this shed times 1 minus alpha times 1 minus alpha plus over P2 plus Q1, this whole thing over P2. So, right? All right, that's P1. And okay, we're losing battery. That is our P1. Oh shoot, we're losing battery. So that will be our P1. Once we set P1 as this, what will happen? We want to maximize U1 max on B1 is P1 P1 minus MB1 U1 equals P1. Sorry, I have to talk to you, I forget. P1 equals P1 times this plus Q1 plus Q1 minus M B1, right? Then we have U1 equals a constant plus, what is the coefficient of B1? P1 gamma minus M right? P1 gamma minus M B1. So if we will choose B1 as 0, if P1 gamma minus M what is P1 gamma minus M greater than less than 0, and B1 we choose it as 1, P1 gamma minus M greater than 0. All right. Then we have to check all of our previous constraint, by the way. Okay. So P1 gamma minus M greater than 0. B1 will be 0 and P1 will be this. Because it depends on M. M can be very big and you don't want to pay, right? So it's not just, so that's it. Minus gamma B2. Minus gamma B2. Okay, now let's see what happens for the best response to this best response, right? What will be Q2 and P2? Um, so we know that we are on B prime, S1 plus gamma B1 is greater than S2 plus gamma B2. And we will have what is U2? Oh, okay. U2 is where is the formula for U? Okay, U2 will be P2 minus MB2. P2 P2 minus MB2. So the other guy is trying to maximize P2 minus MB2 over P2 and B2. What is the constraint here though? Well, this constraint holds, right? This constraint holds because of our choice of P1 and B1, the constraint holding. So, we choose P2 as the maximum, which is bounded by Q2, and B2 is just an assumption I have, as minimum to 0, right? So P2 will be Q2. B2 will be 0. Now we need to check the constraints. So, okay, then, by the way, P1 will be Q1. Funny, huh? P1 will be Q1 and B1 will be 0 as well, right? Checking the constraints. Okay, P1. That was a condition. P1 gamma minus M should be 0. Okay, that's an assumption. Which we assume holds. Then what? That holds, this inequality holds. And S1 and S2 will be both 0. Because R1 and R2 are 0. Okay, exactly. Are we in B prime? B prime says B prime A is 0 greater than 0 and B is also 0 greater than 0. So we are not. I don't like this. At least there is something wrong here. Now let's go. This is the assumption. P1 gamma minus m less than 0. Or greater than 0. You have to come back and clear everything. P1, like summarize gamma minus m greater than 0 assumption, and we are on B prime. Oh, sorry. P1 gamma minus, then B1 will be 1, right? V1 will be 1, P1 will be, what will be P1? P1 will be this. P1 will be this. Now we want to maximize P2 to the maximum. P2 will be Q2. And B2 will be 0, right? Yeah, I will not buy sponsorship if my score is low. And I set my price as high as possible. Okay. Now we should check if we are in B prime. A P1 R1 1 minus alpha gamma B1. So it's just P2 R1. This is the constraint we need to check. P2R1. Right? So this is the constraint we want to change. This is 0. And P2R1 plus gamma B1 should be great. So P2R1, which is Q1 minus P1, which is P1 then we can also say P1 will be 0. P1 will be, so Q2 minus P2 will be 0. B2 is 0, so it will be gamma 1 minus alpha. You cannot set it like that. That doesn't make sense. If I am bounding P2 by Q2, I should be, for P1 I also needed to be bounded by Q1. Yeah, this is assumption I have, because otherwise, yes, those firms can set their prices as high as possible, and because I'm assuming consumer will buy anyway, so there is no incentive for them to just, yeah, we should have price less than quality. So this doesn't work. So this doesn't work. It means that exactly, it means that okay, here, I don't know if we said the P1 as Q1 or what, but I think it will be the same. When did it happen? When we missed it? It was here, right? It was here that we missed it. So we have this extra assumption that P1 less than Q1, right? And here it says that this is the constraint that is binding, not the other one. So we are maximizing it's just so many. P1 is Q1. Uh, P1 is Q1. Then we have to maximize U1 or minus MB1 subject to, so we want B1 to be as low as possible, but we need to have the constraint which says gamma B1 greater than P1 Q2 minus P2 1 minus alpha plus gamma B2, right? For that, we can say B1 is 0, either B1 is 0, which is better for the utility 1, but we need to have 0 less than P1 Q2 minus P2 1 minus alpha plus gamma B2, which this one is greater than or equal to 0, which suggests that again P2 is Q2 and B2 is also 0, something we don't like. The same in equilibrium. Or we have B2, B1 is 1, then gamma P1 Q2 minus P2 1 minus alpha plus gamma B2, right? And now we want to maximize utility 2, which is P2 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 minus MB2, right? Now, oh my god, now firm 2 has the option to choose between the two cases we have. Either the first one, his utility U2 will be 0, or the second one, max P2 minus MB2 subject to gamma greater than P1 Q2 minus P2 1 minus alpha plus gamma P2. And here in the utility we want P2 to be as big as possible, which is not in contradiction with like P2 in constraint. P2 in constraint loves a big P2, right? So, exactly. Both of them like P2 to increase. We want P2 here to be big. We want here P2 to be big. So what is limiting P2 is P2 being Q2. And then this one wants, then we have max minus M B2 subject to B2 less than 1. Guess what? B2 will be 0 because this one wants B2 to be low, this one wants B2 to be high, also low, B2 be 0. So that sounds like the thing. So it seems we are here. Both situations, we are both P1, Q1, and here. So regardless of the assumption, we are at the case P1, Q1, P2. Oh my god. P2, Q2, P1, P2, 0, right? And we need to check if we are in B prime. Okay, we are not in B prime. We are on like B prime's boundary. The same will happen with A prime. A prime. We won't end up in A prime or B prime. Dude, I don't like my posture now. Okay. If you had it on the wall, I would miss this motherfucker. Or I should lay on the ground, but I can't. I will get back to the ground. Few days. All right, so let's go A intersection B. What's happening there? Well, in the intersection, we know it depends on the initial state, right? Okay. And let's assume assumption uh, S0 plus gamma B0 is greater than S10 B10. Right? So uh, S10 plus gamma B10, S20 plus gamma B20. So S1 will be greater than S2, S1 plus gamma B1. Then let's maximize the same utility. Max U1, which is P1, P1, MP1, right? Subject to um, this P1 R1 plus gamma P1 greater than P2 R2 gamma P2. Right? Um, mm, subject to these. Well, the constraint S10 plus gamma B10 greater than S20 plus gamma B20 doesn't put any constraint on the stable utility phase. So this is the only two that are left. So and we also have P1 less than or equal Q1. We also have in the back of our mind, right? And so utility wants us to have P1 as big as possible, while first constraint wants us to have P1 as low as possible. Second constraint, so this one wants P1 to be big, this one wants P1 to be small, and second constraint enjoys P1 being big. So the binding one is the second one, and that makes P1 again as Q1. So P1 times Q1 minus P1, 1 minus alpha plus gamma B1, then P2 P2 R2 Q2 minus P2 we will set P1 as the same shit as it was here. So then we have to maximize something time constant B1 constant can depend on P2 and B2. Okay, P1 gamma minus M minus M B1, right? And subject to first one was binding. So the first one is binding, we don't have it anymore. We have this P1 less than Q1 in the back of our mind, and we have P2 R1 1 minus alpha plus gamma P1 less than P1 R2 1 minus alpha plus gamma B2, right? This one so if assumption P1 gamma minus M greater than 0, then objective wants B1 to be great possible, constraint wants B1 to be low. Or something like that. Okay, let's check what will be the constraint. P2R1 P2 R1 R1 is Q1 minus P1, which is 1 minus alpha over P2 P1, right? Over P2 Q1 minus P1 alpha P2 P1 Q2 minus P2 over 1 minus alpha minus gamma P1 minus P2 P1 R2 1 minus alpha minus plus gamma P2. Great. P1 R1 P1 R2, so yeah, P1 R2 1 minus alpha minus gamma P1 minus P2 less than P1 R2 1 minus alpha plus gamma B2. It says gamma B1 greater than 0. So kind of B1, we want to make B1 as big as possible. So B1 will be 1. This guy, because of the assumption, objectively constraint wants B1 also be 1. Therefore B1 is 1. B1 is 1, and then we have this thing that we have to check if P1 stays Q1 or not. u2, which is p2 minus mb2. What is the constraint? Well, these constraints are already addressed, so we want p2 to be high. We set p2 as q2, but b2 to be low. We set b2 as 0. Then p1 will be gamma plus 1 minus alpha over p2 plus q1, which is greater than q1 and wrong. Then we will have p1 as q1. Same thing, p2, q2, and so that's the equilibrium. So P1 R1 over 1 minus alpha plus gamma B1. R1, R2, R0, all of them are 0. Okay. We didn't study what happens when we are like inequalities are binding in the state, but I don't want to get into that. So all of them. All right. It was something we computed before. I think it won't change. What am I doing? I think it won't change if I add the terms to the utility, like utility is previous utility plus, I don't know, 1/2 with probability 1/2 you sell to the price P1. Like, okay, updating rule. S1 T plus 1. Previous term plus, for example, 1/2 you sell and you receive the reward R1 once S1 plus gamma P1 equals S2 plus gamma P2. So actually we can check that too, it's not a big issue. let's assume S 1t plus 1 is alpha is 1t plus 1/2 R1, right? And it's 2. But we know R1 is 0. 0. Fuck it, I don't know. Doesn't make sense. Not nice model. Okay. We have two other models. One is when we have two other models, right? One is when we can have effective buying sponsorship in we can have effective buying sponsorship in the memory of the dynamic system, which is a stronger change. But the other one is the one that we can have just not the sponsorship as 0 or 1. Well, here we didn't assume it is 0 or 1, we just said it is between 0 and 1. So actually we can say this works for that too, right? We have a maximum amount for the power of sponsorship. If we assume that, then it will be the same. It's just a scaling gamma. So I think that's a good model for that too. So we just need to check the effect of sponsorship in the history. I'll be back, I think. Yeah, let's take a break.